So multiplexer. So far we seen packages, operator, dispatchers, adders, full adders, coding part in VHDL. Now we are going to see about multiplexer 2:1, 4:1, and the demultiplexer side 1:4. So the coding we will going to discuss. So the multiplexer, multiplexing. So it's a process of transmitting large number of information over a single line that is called as multiplexer. So this is 2 to 1 mux. Actually 0 1 is there. So there is a input and output is there and select line. So if it is one select line, so based on the select line you will be get the output 0 and 1. So if it is 0, then the output is I0 and I1. So I0, I1, 0 and 1 is there. So based on the select line, it will be select one of the input. So that is max. For example, if 0, the input of I0 will be come to the Y. If it is 1, then this output will be come to the select line. So based on the Boolean expression, it will be I0, I1 and S dot S0. So we have to draw it and we have to connect based on the Boolean expression. So I0 and S dash. Then similarly I1 and S. You have to connect it the S and I1. So this is the way you have to connect it. That's a multiplexer. So 4 is 1 mux. So 4 is to 1 mux, 4 to 1 mux. This is a 4 input, 1 output. So there are two select lines. So based on the select line, when it is 0 0, the first that input will be selected. When 0 1, the second input will be selected as selected and send it to the output. And third 1 0, then that will be selected and send it to the output. So this is 4 is to 1 mux. So the black diagram for 4 is to 1 mux, and this is the truth table. Okay. So this is a logic diagram for 4 is to 1 mux. The select lines are there, and input D0, D1, D2, D3. So the all are connected based on so all the inputs are having D1 and D2. Only input 4 input. So the four input means we know that there are two select line. So two select line, you see it is 0 0 0 1 1 0 1 1. Okay, based on that they will be do that. So AND gate and OR gate. So 8 is to 1 marks. So they have used 8 is to 1 marks. Logic symbol 74151 8 is to 1 marks. So then okay, so these are the things for mux and application of mux data routing, function generator, control sequencer, parallel to serial converter. And for demultiplexer also one single input, there are many number of large number. Okay, then we will see about the coding part. So this is a 4 is to 1, 8 is to 1 multiplexer, 1 is to 4 demultiplexer coding part. So actually previously we see the diagram similarly same I0, I1, I2, there's an input and AND gate and OR gate and expression the given and truth table and the coding part. This is for coding for using data flow modeling. So entity 4 underscore mux, that's the name of the mux, and port input of the mux, the I0, I1, I2. These are the input. Select line 2, select line, there's an in bit, and output only one output, that is out bit. Then end 4 is to 1 mux, there's a header file name. Then architecture equation, that's a body of the program. Then of 4 is to 1 mux, 4 is to 1 mux, header entity, header file name. Then signal, so here we are also use the signal. So s underscore bar, s1 underscore bar, where we are using signal. So this is the place, that is s0 and s1 is there. So inside there is a not gate used, so this is s0 bar and this one is s1 bar. So this is the place we can use as a signal, because the input, yeah, the port inputs are directly we can't show that. So we just use that signal part. Then s1 bar means not of s1, s0 bar means not of s0. and for PQRS. So what is PQRS? So what is PQRS? That is also in the diagram. So this is the place of signal. So after indicate, there is a line is there. So this is the line is we couldn't represent. So they represent as a PQRS. This is also signal. So that's why they put it in signal in part is PQRS as bit. Okay. So what is P? First they mention what about the signals, and P means so S1 bar and S0 bar and I naught. So the output of the place, So this P has I naught and S1 bar and S0. That S1 bar is there. Then another thing is this one is S0 bar is there. Okay. So similarly, they are mentioned about PQRS and equation. So I think so this is data flow modeling for MUX. For behavioral modeling, you have to get it from truth table. So here we are going to use similarly entity is same. Okay, input and architecture and the process S0 and S1 begin. So based on the see the table that our truth table we can say if it is 0 0 select line then it is I0. When it's 0 1, see this. If it is 0 0, they put it I0. Here D0, 0 1, D1, 1 0, D2, 1 1, D3. Like that, they I0, I1, I2, I3, they put it there. So here I0, I1, I2, and I3. So 0 0 0 1 1 0 1 1. So based on that truth table, they will be maintain the program like this and the end if end process and after this is a behavioral modeling. And finally, this is a 8 is to 1 marks using structural model. So this is they are calling first they will be made 8 4 is to 1 marks that is already we completed just to call it and 2 is to marks also we already uh, write the program. Finally, we will call it to get it 8 is to 1 marks. Okay, for Dmax. So this is one input, many output source that is Dmax. So the Dmax, this is one is to four using data flow modeling. So entity four is to Dmax. So this is architecture and signals and begin process. So here we are using I0, I1, I2 and I3 because this is the output for I0. So what is I0? So how will we get the output for this? This is I0, I1, I2, I3. What is I0? The I0 connected to Y, and another one is connected to S1 bar, and another one is connected to S0 bar. Like that, S1 bar, S0 bar, and the Y. The Y always is there, so this is also S1 bar, S0. So this is the way they will be put it. So this is data flow modeling for DMAX. Okay. So behavioral modeling for DMAX they used case statement. So entity everything is same. The only the case statement when a case is equal to s select line when 0 0 means I0 and 0 1 I1 I0 I2 I1 I3. So like that. Okay, and structural model. So this is for a structural model. Okay, so this is basically basics of Mux and Demux coding part. Okay, thank you.